everyone. Before we start, I just send a file. So this is a like file I created to make it easier to like understand what's going on for this portion. Oh shit. Oh, time to introduce. So we'll be going through like past year papers, the G, D, and T portion. So there won't be much drawing. So y'all probably have to take out your calculators and yeah, start working on it. So I'll probably do this in 2 halves. So for this week, right, I'll go through the first half of the G, D, and T portion. So I'll go through 3B and 4A and and probably 4B. I'll leave 4C to the next session. Okay. So before we start, anyone have any questions? Oh, the paper we'll be going through today is the 2021 2020 semester 2 paper. So it'll be helpful if you have the paper out as well and you do it along with me. Yeah. So I'll give you a bit of time to take out, like find the paper, and if wait, let me just send it if y'all can't find it. I'll just send it in the group. Yeah. Here. Okay, this is the previous semester's paper. Oh, it's quite big. Yeah, I'm sending it in the Telegram group, so y'all can access it from there and I'll open it. So I'll just give you a yeah. Also, if you have any questions, feel free to speak up. Yeah. Okay. Yeah. Okay. Okay, I'll begin. So to start with 20 for procedural purposes, this is MA 2005 2020-2021 semester 2 paper. Okay, I'll be starting with question 3B. So question 3B, determine and enter the missing dimensions into each of the tables as shown in figure 3B. Okay, so for this, right, let's see. Bobby to have a tolerance of 0.102, pushing A to have a tolerance of 0.078, and a minimum interference of 0.089. Okay, immediately when you see this question, right, you can fill in something already because they already give you this value. So what can you fill in? You can fill in the one right below it. Okay, as you see, they have provided that bushing A has a tolerance of 0.078. So what you do in this case is, so for 6.616 minus 0.078. So yeah, once you type into the calculator, you will get 46.538. Okay, everyone can understand that. Okay, I just assume you can. Okay, so the next line, minimum interference of 0.089. Now, what does that mean? That means it will always have like the minimum interference that it will experience is 0.089. So if you can refer, wait, someone message me. Okay, never mind. Okay. So if you refer to the sheet, let me try to. Okay. Okay. I hope it's showing the correct thing right now. So if you can see the sheet, right? So for minimum interference, what you want to do is you take the lower shaft value and the upper hole value. Okay. So this can be thought as a shortcut, like, to figuring out what it is. So you can remember this table if it doesn't come intuitively to you, or let me just try to turn to meeting, share screen again. Okay. So what you can think of this of, right? When they mention minimum interference, that means that it's the minimum interference that you expect. So maximum interference, that means the material will go into one another a lot. Well, minimum interference means it just like you can think of it as a tight fit of the sort. So how do you get minimum interference? So you take the lower limit of the hole, and since this is an interference fit, right? Shaft B will be smaller than shaft A. So you take the lower limit of the shaft, right? Because A is a shaft, and you minus the minimum interference. So you take 46.538 minus 0.089. Then what do you get? You'll get 46.449. Okay. Yeah, 46.449. So that's the value you get. So straightforward. B 46.449 is the maximum for B. So you minus 0.102. Then you get 46.347. Okay. And that's how you solve question 3B. So okay, let's say, right, it's not minimum interference. Let's say they ask for maximum interference. Let's say maximum interference of this value. Okay, so maximum interference, what do you want to like, how will it interfere the most? So if you were to interfere a lot, wait, I got a thing. Okay, so for maximum interference, what you need it to happen, right, is the biggest, you'll have the biggest shaft, right? And if you have a very small hole, like, yeah, okay, this is a bit exaggerated lah, but this will be the maximum interference lah. Like you're trying to shove the shaft into this small hole, so maximum interference. So what will you do? You will take the upper limit of the shaft and well, upper limit of the shaft minus the lower limit of the hole. So 46.616. And maximum. Yeah. So instead of using the lower limit and upper limit, you use the upper limit and lower limit. So you take 46.616 minus 0.089 equals 46.527. Okay. Then accordingly, you just fill in the tolerances that you have to add. You have to plus 0.102 plus 0.102. Okay. And you get 46.629. So this is your maximum interference. Okay. So likewise, right, if you refer back to the sheet, clearance is also the same. So you have minimum clearance and maximum clearance. Okay. So minimum when it has the word clearance, right, it just means that the hole, right, is bigger than the shaft. So this is clearance. And this is interference. Okay, so everyone can understand? Anyone have any questions? Is this what do you mean is this a hole? Which one's a hole? B is a hole, and A is a shaft. Yeah. Clear? Oh, okay. You can see your questions. So if anyone got any more questions, I'll just move on. Okay, I'll just move on. See, in question 2, right, they ask for maximum clearance. So we can apply that knowledge, but let me work on B first. So for B, B 84.633, then you have to add the tolerance for B, which is 0.15. Yeah. So this one, you add 0.150, you'll get 84.783. Okay. Oh, sorry. I missed out one thing here. So, right. Okay. Basic dimensions. So, what is a basic dimension? So, essentially, basic dimension is the MMC, maximum material condition for a hole / shaft. Okay. So, if you remember from the lectures, or if he clarified properly, right? Maximum material condition is for the dimension where this thing has the most material. So in the case of a shaft, right? For shaft is the maximum dimension, maximum upper limit. For hole is for the lower limit. So if you can imagine, right? If you have a smaller hole, you have more material. You have a bigger shaft, you have more material. So that's what it means. So for B, since B is a hole, so you want to maximize the hole, so you make the dimension smaller. So, yeah, lower limit of the hole. Okay, now time to go back. So here,
Well,
yes,
can I ask you a question?
yes,
Okay, this pertaining to the first question, right?
yeah,
When the given tolerance, for example, the bore B to have a tolerance of 0.102.
yeah.
Okay, based on this question, can I assume everything, whatever tolerance is actually given, is an equal bilateral, or how can I ensure that this is not unibilateral?
It doesn't. No, it's just a basic tolerance.
Okay, so whichever for this type of question, we just assume this should be a equal bilateral.
You don't need to assume because it is just a basic tolerance. Like if you were to draw it, it will just be like how to say eh? Hmm. It for this say tolerance, but
Because when I tried to attempt this
it
question, right, there
yeah.
was a lot of question I was asking. How can I ensure that this tolerance is not a unibilateral, which means it's only have a positive 0.102 with negative 0.000.
Oh, because they give you an upper limit, right? Like they set a limit. For example, in this question, the basic dimension, the dimension that you start with, right, is this. So if they give that bushing A to have a tolerance of 0.078, what do you think will go in the lower limit?
I was thinking like just because
Just
it's
just
that's why I want to clarify it, because I assume my 46.616, right,
yeah.
is the upper tolerance, which is
Yeah.
already inclusive of 0.102. Sorry, 0.0078.
Yeah, that's the upper limit.
Okay.
Oh, so if I were to draw that in like GD and T proportions, like
Mhm.
imagine you have a like that, right? Then you'll get a 46.616 and 46.538. So well I mean yeah, it'll look sort of like that if in GD and T. Like
Oh,
this is a like easy question. Like it's not trying to trick you or anything.
okay,
It's
so I
like
can
supposed
straightforward.
to give you yeah, straightforward. It's straightforward.
All right. Okay. Okay. Really appreciate it. Thank you very much.
Yeah. So okay. To say first, right? I honestly um recommend y'all to start with the GD and T portion first. If you practice it once or twice, right? It shouldn't take you more than 30 minutes to complete, and it will get how to say, because it's a very mechanical thing. The questions, let me accept someone. The questions don't really change much over the years, and it's quite straightforward. You're just pressing into calculator, or just make sure you don't press wrong, huh? But it's quite straightforward, as in there won't be a lot of twists, and you're just typing in values. So in this case, yeah, tolerance easy. So just the difference between the top and the bottom is this. The difference between the top and the bottom is this. Oh shit, cancel. Yeah. Okay, great, peachy. Okay, peachy. Okay, so maximum clearance. How would you generate a maximum clearance? So for maximum clearance, right, you want a very small shaft and a very big hole. Okay, yeah. Very small shaft, very big hole. Yeah. So small shaft, lower limit, then upper limit of the hole. So you just take the hole, right? So you take the hole. So 84.783 minus 1.054. Yeah. So this one minus 1.054. Okay, it's visible. And you get 83.729. Okay. So you have the lower limit of the hole. Then you just need to add 0.15. Okay. No, it's not 0.150. You need to add 0.121. Okay. So add 0.121 and you get 83.850. And since it's a shaft, MMC for shaft is the upper limit, so 83.850. Okay. Any questions? Because it's quite it's like similar to the above one. Okay. Okay, if there's no questions, I move on to this one. Okay. So for this one, time to refer to the table. So if you weren't aware, the table looks like the table looks like this. Okay. So I see you have used it for your C4 and C5, but I'll go through again. So what you can see here are the fits. So loose, running, close, sliding, locational, clearance, and it has the numbers on the side. Anyone very unsure about how to use these numbers? Okay, I'll go through again. Y'all feel very unsure. So okay, let me go to the question again. Wrong. Okay. So for this, okay, this one. Okay. So we start with the first half first. So for the first half, you just need to focus on this part of the thing. So okay, they give you a basic dimension, and C is it's a hole. Yeah, housing C is a hole. So what you can write here is hole basis. Hole basis. Okay. Recommend just put this number into your calculator. So just type 82.750 into your calculator. Okay. So okay. So for this, BC, it's a medium dry fit. So medium dry fit. Not medium dry fit, but medium drive fit. English is hard. So medium drive fit between B and C. So let's go to medium drive fit, hole basis. Okay. So okay. Hole basis, yay. Hole basis. And let's find the medium drive fit. Okay. Medium drive fit. Okay. So if you can remember, just now the value was 82.75. So what you look out for is the 80. So let's say it's 89, you still 99, you still can use 80, but if it's 100, you need to go to the next one. And if it's 70 something, you need to use the 60. Okay. Anyone not sure why it's so? Okay, because this is a range from 80. So you can use this number from 60 to 79.99. Yeah. Okay, we start with 80. So one common mistake that a lot of people get, right, is the position of this hole and shaft. Don't be mixed up. Some people just happy just thought like just think like BC, then they just it's like BC and they mix up the columns. So don't mix up the columns. It's not really worth it. So let me let's say copy and paste. Okay, I'll go copy and paste it next to it. So this is all. Okay. Copy and paste the image. It's a medium drive fit. Okay. Let me go to the semester. Okay. Go back. Okay. Yeah. So this is the part I want y'all to focus on. So for this, I copied over, but this is hole H7. This is shaft S6. Okay, don't mix it up. A lot of people mix up the position. It's not worth losing marks at this. You rather lose marks in the first half. Cause yeah, that's where you're gonna lose marks. Cause sometimes you really can't draw the thing because you can't visualize. So you don't want to lose marks in the GD and D portion. Don't careless. Because yeah, well, if you can get this calculation basis clear, you should be fine. Okay, so whole basis, this is the basic dimension. So for a whole, right, is the maximum material condition. So it's the lower limit. Okay, wrong color pen. 82.750. Okay, lower limit. Okay, what is the upper limit? So upper limit, okay, let's refer to this. So actually a very good telltale sign is like, and we can tell that, yeah, this is a whole number. So you can start from here. So what you want to do with your calculator? So you take your calculator, right? Then 82.750, right? You minus 80. Okay, minus 80. Then what do you get? You get 2.75. Okay. So let's say you're doing the 60s column and your value, the value that you have is 79.50. Okay. So 79, you can't use it in the 80s column. So you must use the 60s column. So what you do, 79.50, right? You have to minus 60. Then you get a big number, but don't worry. It's normal. But since you're in the 80s column, you minus 80. The 80s column is from 80 to 100. So let's say this was 95, right? 95, you still minus 80 equals 15. So what do you do with this number? So this number, right, you add it to every single number here. Okay, so what do I mean by that? So okay, the corresponding one is here. So 80.030 u plus 2.75. Once you add 2.75, right? What's the value you get? Or you can add 0.03 to this. So 82.780. 80.030 plus 2.75. You get the same thing. So, okay. So you, 80.030 plus 2.75. You get this. Okay, now for the next one, shaft. So for the lower limit of the shaft, you take 80.059, then you add 2.75. What do you get? You get 82.809. Then on the top one, you just add 80.078 plus 2.75. And you get 82.828. Okay. Everyone can understand? Yes, my understanding it should be. Oh, okay. Okay, great. Glad you can understand. Oh wait. My understanding is usually because it's up to and including. Yeah, let me check something. Up to 1 and including 1. Up to 80 and including. Oh. Yeah. Up to and including to 80. Oh shit. Okay, sorry everyone. Think I got it a bit wrong there. Let me cancel this part. Okay. Okay. Sorry. We are supposed to use the hundreds one. Okay. Apologies. Paste it again. Yeah. So thank you. I think I made a mistake. So once again, it's hole, and this is shaft. Can't see. It's hole and this is shaft. Okay. So copy and paste that wrong one. Okay. Okay. Okay, it's updated. So sorry for the thing just now, but yes, it goes by the same basis. Thank you, Van View, for this. So okay. So likewise, it's similar. So since the basis is 100, right? You take 82.750, you minus 100. Yeah. Let's check something. Okay, so equals to 2.750. Wait, no, Okay, never mind. Yeah. Minus 100. Yeah, equals to negative 17.25. So you take this number, then you minus everything here, here, and here. Okay. So 100.035 minus 17.25. And you get 82.785. Then 0.5. Okay, then for the shaft portion, so you minus 17.25 because 82.843. 71, you get 82.821. Okay, sorry for the confusion earlier. So yeah, this is how you're supposed to do it. Yeah, you take the one that's up to 100. So when it's 100, you can up to 100, you can use like 99. But if you want to use 101, you need to use the next level of if you want to use 101, you need to refer to the 120 column. Yeah. Okay, I'll mention this in text when I upload. So okay. Now now we're done with this, right? We can refer to this portion. Okay. So for this portion, it's shaft basis. Okay. So let's refer to the shaft basis. So shaft basis, sliding fit. So I assume you all know how to use the find where the shaft basis. Okay, it's on the top. So shaft basis sliding fit for 53.465. So 53.465, I need to use the 60. Yeah, the ones in 60. So copy. Okay. Look, okay. So this is hole. And this is shaft. Okay. Okay, hole and shaft. So for a shaft, what is the basic diameter? So the basic diameter for shaft is the upper limit. So 53.465. Okay, 53.465. You realize that it will correlate to here lah. So 53.465 minus 60 equals to 3.465 minus 60. Negative 6.535. Okay. Then you can continue to the bottom. 59.981 plus this value equals to 53.446. Then you add it to this value as well. Plus 60.040. Get 53.505. You add it to the last value, 53.475. Okay. So that's the yeah, that's how you solve the question. Anyone have any questions? Okay. Okay. So if what? Okay. Now let me move to that. So when you refer to that right, medium drive fit between medium drive fit right between bushing B and C. So you go to here. Medium drive fit. So you see H7 and S6, right? Okay. Yeah. Medium drive fit between B and C. So H7 S6. Then for sliding fit, shaft basis. Shaft basis, sliding fit G7H6. G7H6. Okay. Everyone PG? Okay, great. Okay. I shall move on to this portion. Okay. So for this 4A, if you refer to my small cheat sheet thingy, 4A, right? So basic size, what's the basic size? MMC conditions for hole and shaft. So what's the MMC condition for hole and shaft? So shaft is the bigger one, then hole is the smaller one. Okay, so this might sound weird, right? But you just pick the one that has the nicer number, like it's a multiple of like 5, or okay, so you pick one nicer number, then you look towards less dp. So for example, what do I mean by less dp? That means 72.470. So if it's 470, right, you pick it. Yeah. So 72.475 versus like if these two versus each other, right, you still pick this one because it has lesser dp. But if it was 7.1, right, you'll pick this one. Yeah. So in this case, it's 72.475. Okay. Now, lower deviation of part A. So what is the lower deviation of part A? So, okay, go to there. Okay, so part A, lower deviation. So in this case, the lower deviation is this portion. Lower deviation. Okay. So lower deviation, you take 72.475. Then you minus 72.449. You'll get 0.026. But since yeah. So meaning we'll choose the nicer number. Oh, okay, no. You identify the MMCs for both cases first. Then you compare the numbers. Which one's like technically nicer? Like, yeah. I mean, lesser DP is still nice. Because if you have a 72.410, it will still be more ideal than 72.415. Yeah. Okay. Okay. Since A is smaller than this number, right? Put a minus. Okay. So upper deviation of part B. So what's the upper deviation of part B? It's just the difference between the basic size and the upper size. So as you can see, the upper B is bigger than well, B is bigger, so 0.0006. Okay. 0.006. Okay. Now the next one, allowance. So what is allowance? Allowance is just minimum hole minus maximum shaft. Okay, so in this case, minimum hole is 72.475 minus the maximum shaft is 72.479. Oh, okay. There you get negative 0.004. Yay. Okay. So, and in this case, what kind of fit is it? Where you realize that it's a transitional fit. So there's three types of fit: clearance, transitional, and interference. Okay, so for these three cases, right? Transitional, that means there are some, okay, like for example, okay, no, clearance is easier to explain. So for clearance, right? Clearance, that means the pieces can slide through each other easily. That means even at the maximum shaft, minimum mean hole, like the maximum shaft, right, is still smaller than the minimum hole. You understand why? Because like for it, so the biggest shaft, right, will still be smaller than the smallest hole. Yeah. So it will be able to go in. So this is the maximum. Like, you don't care about minimum because if it's smaller, it doesn't matter. So maximum shaft, minimum hole. Then the opposite of for like the opposite is for interference. Like interference, that means like shaft will the shaft will always be bigger than the hole. Yeah. In this case. So the minimum shaft max hole. So it will always interfere. So for transitional, right, it will be sometimes interferes, sometimes clearance. So as you can see from this, right, so for the maximum hole, right, then okay, let's just take from one. So maximum shaft. So if you have the maximum hole, it's a clearance because the hole is bigger. However, if you take the minimum hole, it's smaller, so it's like cannot it can't go in because interference. So that's the idea. Transitional sometimes can go in, sometimes cannot go in. Then for interference, it's always cannot go in. Then for clearance, is always can go in. Yeah. So anyone has any questions about that? No questions? All right. Okay. No. Okay. So for 4C, right, I'll probably go through it next week because it's quite long. And yeah. I also have to clarify a few things with the prof first. But for the 4B, right, okay, I'll go through it now. So the interesting thing about 4B, it was a brand new type of question that just came out for last semester. So if you do PYPs, right, there's only one of this type of question to refer to. So yeah, I suggest y'all do it. Cause Prof Thor likes to repeat the same questions for a few years until people like get the hang of it. Then he changes it into some brand new question. So it's important to grasp the basics. But I'll go through this because it will make more sense to y'all. Because it will probably stick to this kind of format. Okay. So let's attempt this one by one. Okay. So maximum permissible value of A when C is 156. Okay. So let's go here. So let's say, okay, C, right? So the distance between each of them, okay, is 156. So what you want to do here, right, is make it so that A can be the biggest it is. Now this is a very confusing topic for most people because you don't know like which one you make longer, which one you make smaller. Because it's really not intuitive. So okay. So the thing you need to take note is one, there are two very important things that cannot change. So the holes, right, cannot be bigger or smaller than these amounts. So that like the shaft cannot be thicker than 73. The hole cannot be bigger than 23.006. So that those are the two things that stay constant throughout the holes. The things that change, right, are this. This can be bigger or smaller. If this wasn't specified to be 156, right, it could be bigger or smaller also. Like if this wasn't specified at 156, you could make the shafts closer to each other as well. So you could make them like 156 closer. Okay, but the only restriction that you have, right, is even if you shrink this, so you push this in, or you expand out, right, this shaft must still be able to go into the hole. So what does that mean? Okay. So let's say you move this hole to the right. Like move them closer to each other. Okay. So you move it closer, closer, closer. So what's the closest you can push the two holes together? Like the closest you can push the two holes together, right, will be when this shaft wall here touches this wall here. Okay. Yeah. So like that's the closest you can go. So how to say, you can keep going until this is in. So when I push this thing in, right, the shaft will be here. The shaft will be here. So it's touching. Okay. That's one of the things. If I want to shift the holes out, right? So what part will be touching? Here, here. Because I shift the center point of the hole. So the shaft will be here. Then you have an empty space here. Yeah. Once I go like shift the shafts in. So you have empty space here. So essentially that's what the question is talking about. How much can you shift while making sure that the shaft will still be able to fit into the hole? Okay, hole. Okay. So it's kind of a thinking problem. So okay, when C, what's the maximum permissible value of A when C equals 156? So C in this case is 156. Okay. So C is 156. So the center points of this, right, are fixed. The shaft cannot change anymore. What can change is the value of A. So maximum permissible value of A. So you need these center lines to be further apart. Well, you want them to be further apart. So, okay, how will it be further apart? So you shift the hole to, you shift the hole like that. Okay. Okay. Then the. Okay. So you shift the holes apart. So intuitively, when you shift the holes apart, you make A bigger. Right. The shaft will touch the inner side of the wall. So you have this kind of situation. Okay. Let me draw it as a square. So you have this situation. Okay. Okay. So let me redraw it so you won't be confused. Okay, I'll draw it here. So in this case, C, right? Okay. It doesn't change. C. It's still 165. So this doesn't change. But A, I shift it out, right? And this change color. Okay. Then I shift it out, so it'll be touching. Okay. Okay. This will be A. Okay. So how do I get the biggest A? So to get a big A, right, let's just focus on one side. To move out as little as possible, so you need a small shaft. Because, oh shit. Okay. To make A as big as possible, so you need to have a small shaft amount. So this is the I would say least. Okay, so you take the minimum, then you move out. You move left the least, then you move right the most. Okay, and what am I referring to? I'm referring to the tolerances here. So the tolerances for the shaft, which corresponds to the least, so it's 73.03 plus 0 minus 0.006. So least, you take 73 minus 0.006, you get 73 minus 0.006, get 72.994. Okay. Then most, what am I referring to? I'm referring to the shaft. So I'm referring to this. So in this case, it's just a simple 73.006. Okay. So what you want to do here is, okay, you take this amount, right? This amount, yeah. Okay. Okay. I know you're compelled to divide. You divide this by 2, divide this by 2, divide this by 2, then just add it into here. Because these are all radiuses if you understand. So this is the radius of the shaft and this is the radius of the hole. But you don't actually need to do that. What you can do is 165, right? Since it's moving in, it's a small amount, right? So you minus 72.994. Then you plus 73.006, which equals to 165.006. So the maximum value of A when C equals to 165. Oh, 156. Sorry. 156. Not 165. 156. Because 156.006. So the first one is 156.006. Okay. Everyone PT? Okay. Okay. Moving on. So what is the maximum permissionable value? I got 0. Huh? How do you get 0.12? Oh wait, 12. Mental math not good. 12. Yeah. Okay, 12. Okay. Yeah. 156.012. Thanks for the correction. Okay. So maximum permissible value of B when C equals to 156. So it's how big B can get. So what limits how big it can get? So for B, right, it can keep getting bigger till it touches the sides of this. Okay. Sides of these walls. So for that, right, B is the biggest when the two shafts are the smallest. So if the shafts were smaller, right? B could be bigger. So what you want to do here? So when the shafts are smaller, so it's this amount. So 23 minus 0.006, which you already found out from the first half, it's this amount. So you just take 156 minus 72.994, which is 83.006. Okay. Okay, moving on. Minimum permissible value of C. when A equals to 156. Okay. Now you change. Now you're coming from the top. So A must be 156. So technically, right, you're not moving this thing anymore. It doesn't move. It stays still. The only thing you can move is the sizes of the holes. But 156 it stays constant. Okay. So since 156 constant, we have to edit this, like change this portion. So minimum permissible value of C. Okay. So what's the smallest C you can get? So C, to get smaller, you need to move it nearer. So to move it nearer, that means it will contact here, this, and this will have contact. Okay. So to have a small C, right? Small C, you need to move in more, right? Then move out smaller. Okay, I can understand. So to reinstate, you move in more, then you move out small, then C will be smaller. So this is tolerances. So okay, then you get 156, right? So you move in more. So you move in maximum for this. So 13.006. Then you move in small. Okay, move in small. So you have to add because you move out. Okay, you move out in the outward direction. So you add length. So you add length, the smallest one is 73.006. Oh, no, the smallest one, 72.994. 72.994. Yeah, 155.988. So that's the smallest possible value of C. Yeah. Okay. Then minimum permissible value of D. So what's the minimum permissible value of D? Remember, once again, you can't shift the top because they told you that A is constant, so you don't need to think about touching the top part. So D, how is D the smallest? So D is smallest, right? When since you can't move the center points for the two holes, right? D is smallest when the holes are the smallest. Because this wall is actually wait. D, wait, let me change that. Okay. Okay, D is the smallest when you can't move A. D is the smallest when you move in more from A, then out by D. So you move in by the whole length. This is whole. So you move in by maximum hole, then you move out by minimum shaft. Okay. So okay, let's see. 156. You minus the maximum hole, 73.006. Then you add the minimum shaft, which is 72.994. Then you get 15. Oh, wow. Same. Yeah. I think it has screwed up there. Okay, 155.988. No, wait. Sorry. Shaft. Oh, you need to times 2 the shaft. Yeah. Yes. Yeah, you need time 2 the shaft. So it's 228.982. Because you're not moving to the center point of the shaft. You're moving to the outer edge of the shaft. So for D to be the smallest, is to move lesser. So this is minimum. Minimum. So minimum shaft is this. So but you need times 2 because after you move in for your whole calculation, right? You only get this length. So you need to add one shaft, add second shaft. Yeah. Okay, everyone can understand this question?
Bro, if you don't mind, can you repeat again, bro? Because I totally lost the entire part.
Huh? Totally lost.
Yes.
Okay. Okay. The entire part. You should stop me earlier.
Maybe okay. Maybe we can
Okay.
go the first column
Ask.
first.
Ask me. Tell me what you understand from the first column.
No, because from my understanding, right? Okay, the maximum permissible value of A when C is equals to 156. Okay,
Yes.
the 156 is a fixed value. We
Yes.
can't do much anything on that. The only thing that we need to do is the shaft using the tolerance, whether we make it nearer to each other or apart from each other.
Correct. So that
Or,
means we use the first one as example, right?
okay,
So
no
that
problem.
means the center point of these two shafts are constant. 156.
Oh,
Understand?
okay. All right, okay.
Okay, then next. What do you understand about the question?
Okay. Can I clarify when they mentioned the maximum permissible value, right?
Yeah.
Which value actually which the value are we looking for?
Okay, so maximum value of A. So this is A, right?
Yes, you're right.
Okay. Then okay. Okay, or let me rephrase it. So it's the maximum value of A when C equals to 156, right? I
Okay.
just add one sentence to the thing where the shafts can still fit into the hole.
Great. Okay.
Okay. So the maximum how big can the distance between the center points of the holes, like how far can the holes be apart where you can still like put them together? You understand that portion?
No, I didn't get it.
No, like
Mhm.
like you keep moving. When you increase the length of A, right? What happens?
Okay, when we increase A, okay, the C is fixed, which is
Yeah,
156.
C is fixed. Yeah.
Okay, can I know how far can I move the A value? Where is the A value actually?
That's what we are trying to figure out. So the
Oh, all
A
right.
value in this case, right, is the
Mm-hmm.
distance between the center points of the two holes.
Oh, okay, all right. Uh-huh.
Because you can see the arrows here, right? A, I mean,
Yes,
if
you're
this
right.
was GD and T, then I mean, from the value I calculated 156.012. So in GD and T, this makes sense. Do you agree?
Yes, agree, because I can see the A is actually larger than center point of both shaft, which is
Okay.
156.
Okay. So I just put this in where the shafts
Okay,
can still fit in the hole.
all
So
right.
okay, technically we can make A bigger and bigger and bigger.
Okay.
But then your holes still have a tolerance to follow. Agreed?
Yes, agree.
Okay, okay. So the tolerances are still something you need to follow. Okay. So if you were to move A out and out, what portion will how to say, okay, So you have here you got 4 surfaces, right?
Okay.
4 surfaces. If A were to keep going out, which surfaces would touch? Like if you were to if you like put them together.
Okay. The maximum, okay, 156. Okay, the
No, don't think about lengths. Think about which surfaces touch each other. Because that's something you have to take note of. Like surfaces as in this.
yes, correct. If I extend the A,
Yeah.
the inner wall will touch the inner shaft.
Okay. So
Yes,
inner wall will touch the inner shaft, right?
yes, you are right.
Okay.
That's the
So
maximum, right?
yeah, maximum. So I refer you to, okay, let me redraw. So will you agree or look something like okay, ignore my drawing, but so this is the shaft.
Okay.
This is the hole.
Yes, correct.
It'll look something like that, right?
Yes, you're right.
Okay.
So
So
that
don't draw it on the other side. So okay. Okay, do something like that. So the shaft is touching, then there's like an air gap here.
yes, you're right.
Okay. So now the job is to find out when it's touching, right?
Okay.
How big this is. So okay, how big can it be? So okay, now it's time like you have to think a bit. So for it to be touching and A to be the biggest, it can be, right?
Okay.
So you'll move, what you want to do is you move out. Okay, you minus a small amount. So you find out where the wall is. So to move a small amount, but if you move a big amount, like let's say these are the ranges of the shafts. Okay, the shaft can be this small, or the shaft can be this big. Okay, would you rather, to make A bigger, will you move the smaller amount, this smaller amount, or the bigger amount? Like
The small, the
yeah, the
smaller
smaller,
amount will give me maximum A.
yeah. So smaller amount. So in this case, the small amount is 73.006 minus 0.06. Correct? That's the
Okay,
smaller
okay, okay.
shaft.
Can I just clarify this? 73.00 from the shaft diameter, right?
Yeah.
From diameter, we minus the lower tolerance of the diameter, which is 0.006.
Yes.
Okay, that will be give me a smaller version of the shaft. Yes, okay.
Yes. Okay.
Then next, what do I need to do? The whole
What do you
I need to
think you
plus.
need to do if you
I
want
think
to?
the whole I need to plus 73 plus 73 plus 0.006, is it?
Yes.
Okay.
Yeah.
So that give me the bigger
Biggest
hole.
possible distance between the center points.
Okay. All right. Okay. Okay. These two I got it. So which okay. From there, how can we move on?
Okay, then we can. I mean, I would say that okay, we move on to B. Okay, so B, right? So maximum value of B. So okay, so maximum value of B. I think B should be more straightforward. So if you want B to be bigger, right? Like you keep expanding B, keep making B bigger. Well, where will it touch?
The outer wall.
No.
Okay.
If B keeps getting bigger, where will it bang into first?
When the B is getting bigger.
Yeah, because you were trying to find the maximum B. As with the first
Okay.
one, C does not move. C does not move.
Okay. The inner shaft, the inner wall of
Yeah.
the shaft.
So this is the inner, right?
Yes, inner wall of the
I
hole.
should draw a different color.
Okay.
Okay. So inner wall of the shaft and inner wall of the hole. So this is the part that like it will hit first, right?
Yes, you're right.
Okay, so what is limiting B's expansion is the distance between like this is what limits B, how big B can be, right?
Which is one. Okay.
So how to make this length bigger?
Or
You
how to
use
make actually the B length bigger, right? Or
yeah.
having a B length bigger, I need to have again I need to have a smaller shaft.
Yeah, you just use a smaller shaft.
Okay.
So in smaller shaft in this case is
73.00 minus 0.006. Okay.
yeah. Then
Oh,
you yes. Yeah, get it? For this part.
okay.
Okay.
Oh, all right, all right, all right. Okay.
So
I
it's a
think
lot of like you imagine that you set one thing constant first. So A is constant, right? So A now it's the second half. A is constant. So this whole portion doesn't move. So this is 156.
okay.
Then you're just playing around with the second half. Like you're trying to make it fit while taking extremes. Yeah. So minimum permissible value of C.
Oh.
So C is the so as you reduce okay, I test you again. So which faces will touch first when C gets smaller? A stays the same.
When C gets smaller,
Yeah.
A's remain. I think still the inner shaft, right? The inner
Yeah.
shaft wall.
Still the
Yes.
inner because when the shafts get short, like it will touch the inner thing.
Oh, yes, correct.
Yeah. So it's
Oh,
the same thing. So minimum permissible value. So how to get a minimum? You you have to move in the maximum, right? Move in as much as you can. Because you want C to be smaller. So you want it to be as close as possible. So A will move in as much as possible. Then you move out. You move out like move in as much as possible.
oh, okay. So which means
And
first thing what I need to do is
C
I need to
will
know which is the constant first,
yeah.
then followed by the movable, either minimum shaft or the maximum shaft.
Yes.
Okay, 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 bro. I really appreciate. Thank you. Got it.
Then you can apply that for everything. Like with
Okay.
that in mind, right? It will apply for like the other year's question as well. It will be outdated for you, right? Like
Yes, correct.
like it should be outdated. But
Yeah, I'm thinking about
for
this.
last time, they just took one value and they just applied. But with that knowledge in mind, right? You can work it out for any year, and you shouldn't like you'll be able to tackle any question. Just like you keep one constant, then you just shift everything else around. Okay, great. Anyone
Alright.
else got any question? I'll leave it there because 4C requires a lot more thinking than the rest. And yeah, I think it's too much for one lesson already. You all will overload. So anyone got any questions here for from here to here? Any question? Just ask them. If you don't want to ask now, you can find me online. Yeah, on the Discord. Yeah. The guy fans XD. So yeah. SP. So any question? No question, just like I don't know, react with a smiley face or something. So you're like fine.
Most of the questions they ask is we can also either look it on the maximum value itself, right? Like for like part B itself, we are just taking it as the minimum value of that. Sorry. Like
Oh,
we just
B
looking at
says
the shaft
maximum,
itself.
right? Sorry.
Yeah. I mean like we taking it like uh when C is fixed, then we just look at B, right? For B is
Yeah.
just the value that can be changed from, we're just looking at the tolerance itself. Me, like there's two ways to look at it, right?
I guess you can look at the tolerance, but I would like no, we take one step at a time lah.
Okay.
Yeah.
Can.
But like you can think of it in terms of tolerances, but then it might not. Some people it's a bit hard to understand. So instead, I prefer the shifting thing. Yeah, the shifting idea.
Okay, understand.
Because it's more visual, then you can work on it. Anyone got any more questions for this first? If not, okay, never mind, I move up. So your question for 3B, how do you know the type of fit? Like for H7S6. So H7S6. So BC, right? BC is the medium dry fit. So if you find medium dry fit with a whole basis, so let's go to whole basis, like whole basis. Medium dry fit, right? H7S6. Can? Understand. Okay. Just take the order it's in. So H7S6. Great. Okay, anyone got any more questions? I mean, this should be okay. Just don't mix up your minus signs. Like this is smaller, so it's minus. This is more, so it's plus. Yeah. Just practice a bit. Aim to complete this whole section in 30 minutes. Because you really need more time for the front portion. Like, yeah, don't waste time on the back. It's 3 marks. This is the only marks that you can confirm. Because this stays the same every year. This doesn't. Yeah. So just get your marks from here. Okay, any more questions? The front one is cancer. Yeah, the front one is cancer. That's why the back one just math. Just don't punch calculator wrongly. Yeah. I mean, that one I also can't save you. But then again, I think for this paper, right, this was the paper I took. I think I pressed the calculator wrongly for this question also. Yeah. So yeah, don't make careless mistakes, which is hard, I guess, but just make sure you don't screw up. Maybe check twice, but do it fast. Yeah. Any more questions? Okay. So for the types of fits, right? Okay. So clearance, that it just means that how to say clearance, right? That just means the parts will not intersect with each other. It will slide cleanly. There will not be a portion where the dimensions intersect. So example of a clearance one, right, is let me try to find a year where they give clearance dimensions. Okay. So for this one, okay, I see it's close lah, but it's still clearance. So even though it's the biggest, it's the biggest shaft, right? So 7650, right? Then this one is also 76. Actually, this is not a good example. Let me find another example. But that one is clearance. Because the biggest shaft and biggest hole, they in a perfect dimension, they won't touch each other. They will slide perfectly in along each other. So it's clearance. So let me try to find a clearance question. Oh, this is transitional. And this one I never do, but is it clearance? Nope. This is interference again. This. Okay, I'll just make my own. No, I remember there's a clearance. No. Screw it. Okay. Let's say the minimum is 72.47, right? Then the maximum for the shaft I changed it to 72.46. Okay. So at no point, right, will the shaft interfere with the hole. Because even the smallest hole is still bigger than the largest shaft. So that's clearance. Okay. So transitional, right? So this is 72.779. Let me draw it out. Okay, imagine this is the maximum shaft. Actually, let me just 22. Okay, 22.5 and 72.4. Okay, 22.5, 72.4. So the shaft will from here. Actually, no, draw here. The inner limit. Outer limit. Okay. Inner limit, outer limit. Then for this, 72.481. Okay, 72.481. Okay, the maximum. Okay, choose another color. Let's create the pink. Okay, pink. Okay. Okay. See, the maximum hole, right? The biggest hole can still fit the biggest shaft. But then, okay, now for the smallest hole. The smallest hole, let's use blue. Okay. Smallest blue. Okay. So the smallest blue, right, will have a bit of interference. Because it will still jam into each other because it's off by you see here? Negative 0.004. So it'll still jam. But there are some parts that it can go in, like the pink and red. Yeah, it can go in fine. But the green and blue, you have interference. So that's transitional. Okay, let's say for interference, right? That just means no matter how much you jam, right? It doesn't fit. Let's say, let's give it a third one. The maximum for the shaft is 24. The minimum for the hole is like, I mean, I'm exaggerating. Yeah, let's say 72. So like, cannot go in lah. So it'll be I wrote here. Oh, but interference, you have to take account for all things. Even the smallest shaft, right? You also cannot squeeze in. Like you squeeze it down, maybe 70, 72. Then this already biggest. You like pull it open wider, like 72.8. Like this is the biggest the hole can go. You still can't stuff it in. So that's the idea. So that is an interference. It will always interfere. Even with the smaller shaft and the biggest hole. So main shaft, big hole. Yeah. Great. Anyone have any more questions? So glad got people come today. Yeah. If there's no more questions, I will end the session now. So just react with a smiley face if you're okay. Yeah, just aha. Smiley face. Yeah. Smiley face. Okay. No sad faces, I guess. So okay. Thanks a lot. Recording.